Why anyone who goes to Mars will never come back. There are moments in human history when we stand at the precipice of transformation, when the accumulated knowledge and capability of our species reaches a critical threshold, and we contemplate what we have long imagined, the reaching out beyond our ancestral home toward another world. Mars has haunted human imagination for millennia. We see it in the night sky, that rust-colored wanderer, and we have always known that it is different from the other stars. It moves against the stellar background. It brightens and dims in a rhythm that seems almost alive, almost purposeful. The ancients named it for the god of war, perceiving perhaps something restless and challenging in its ruddy light. But in our modern age, Mars has come to represent something far greater than mere military conquest. It represents the question of human destiny itself. When we speak of going to Mars, we are not speaking merely of a technological achievement, though the engineering involved is indeed monumental. We are speaking of a fundamental decision, the willingness of human beings to leave behind the only world we have ever known as a living, breathing environment. We are speaking of the choice to permanently alter the trajectory of human civilization. And perhaps most profoundly, we are speaking of something that has rarely been articulated in the grand narratives of space exploration: the fact that anyone who successfully establishes themselves on Mars will, in virtually all realistic scenarios, never return to Earth. This is not a failure of will or ambition. It is not a tragedy born of technical limitation alone, though limitations will certainly play a role. Rather, it is an inexorable consequence of orbital mechanics, the thermodynamics of interplanetary travel, the biological realities of human adaptation, and the economic fundamentals of space civilization. It emerges from the very geometry of the solar system, and from the nature of planetary bodies themselves. To understand why this must be so requires us to think deeply about what we are doing when we send human beings to Mars, and what we are fundamentally asking of those who volunteer to make such a journey. The romantic vision of space exploration, forged in the 20th century through the achievements of pioneers like Wernher von Braun and Konstantin Tsiolkovsky, has often centered on a model of frontier expansion borrowed from Earth's terrestrial history. We imagine space travel the way Europeans imagine travel across the Atlantic, as voyages undertaken by those who would eventually establish connections between the old world and the new, with the possibility of return ever present, ever possible. We read about the great age of exploration, where ships traveled from Europe to the Americas, and we assume that space exploration will follow a similar pattern. Settlers will go to Mars. They will establish communities. And eventually, those who wish to return will do so, traveling back across the interplanetary gulf to Earth. But space is not the ocean. Interplanetary space obeys different laws. The distances are vaster, the fuel requirements exponentially greater, the windows of opportunity more constrained. Most importantly, the physics that makes return possible on Earth, the ability to travel roughly the same path in reverse, to return to where one began, becomes radically complicated when we are dealing with orbital mechanics and the movement of planetary bodies. This is an exploration of that reality. It is a meditation on what it means to commit to permanent exile, not through failure or accident, but through deliberate choice and fundamental physical law. It is a consideration of human beings arriving at Mars and recognizing, with perfect clarity, that they will spend the remainder of their lives on that planet. It is an examination of what this choice reveals about human nature, about our capacity for commitment and sacrifice, and about the forces that drive us to explore even at the cost of everything we have ever known. Let us begin with the most basic question: why can't the first Mars colonists simply return to Earth? The naive answer, because the journey back would be too expensive, contains a kernel of truth but misses the deeper reality. The question of return is not fundamentally an economic one. It is a thermodynamic one. It is fundamentally written into the architecture of the solar system itself. Consider the simple fact of orbital mechanics. Earth and Mars are not stationary objects in space. They are in constant motion. Traveling in elliptical orbits around the Sun. Earth takes approximately 365 days to complete one orbit. Mars takes 687 days. This difference in orbital periods means that the relative positions of Earth and Mars change continuously. There are moments when Earth and Mars are relatively close to one another, distances of 54 million kilometers, and there are other moments when they are on opposite sides of the Sun, separated by more than 400 million kilometers. This variation matters profoundly for interplanetary travel. A spacecraft cannot simply fly directly from Earth to Mars on a whim. Instead, it must travel along what is called a Hohmann transfer orbit, a path that takes advantage of the orbital mechanics of both planets to minimize fuel consumption. This path is not a straight line. It is an elliptical orbit that touches the orbit of Earth at one point and the orbit of Mars at another. The spacecraft launches from Earth when the planet is in the correct position, travels along this elliptical path for roughly 9 months, and arrives at Mars when Mars is in the correct position to intercept it. Critically, this window of opportunity comes around only once every 26 months. You cannot launch a spacecraft to Mars whenever you wish. You must wait for the planets to be in the proper alignment. You must wait for the geometry of the solar system to create a trajectory that is physically possible and reasonably fuel efficient. Now imagine you are a person who has traveled to Mars. You have spent 9 months in transit. You have arrived at the red planet and begun to establish a settlement. You have invested months in becoming acclimated to the Martian environment, in setting up habitat systems, and beginning the work of establishing human presence on this world. The question naturally arises, when can I return to Earth? The answer is not, whenever I wish. The answer is, in 26 months, if a spacecraft is available and prepared, and if conditions allow. Imagine further that you are one of the first generation of Martian settlers. There is no established infrastructure for return. No shuttle service operates between Mars and Earth. You and your companions have arrived with equipment designed primarily for staying and surviving, not for returning. The spacecraft that brought you to Mars was not designed for a return journey. It was designed to land, to function as initial habitat, and to remain on Mars as shelter and equipment storage. Its return was never part of the mission architecture. Even if such a return vehicle had been sent alongside your lander, even if the engineers on Earth had anticipated the need for homebound transportation, there remains a deeper question: energy. To escape Mars' gravity and return to Earth requires energy, lots of it. The spacecraft must accelerate to Mars' escape velocity, which is about 5 kilometers per second. It must then travel back across the interplanetary gulf in a return trajectory that will take another 9 months or so. It must finally decelerate as it approaches Earth, fighting against Earth's more substantial gravity well. All of this requires fuel. A great deal of fuel. More fuel than the return spacecraft can reasonably carry, given the constraints of what can be launched from Earth and landed on Mars. This is where the cruel mathematics of the Tsiolkovsky rocket equation enters the picture, that fundamental formula which relates the change in velocity a rocket can achieve to the ratio of fuel mass to dry mass of the vehicle. As rocket scientists have known since the early 20th century, the equation is exponentially demanding. To double the delta V, the change in velocity, you can achieve, you must roughly square the mass of fuel required. Small changes in the amount of velocity you need become enormous changes in the amount of fuel you must carry. A spacecraft departing Earth for Mars, unencumbered by the need to carry a return vehicle and fuel, might use a relatively modest amount of propellant. But a spacecraft that must land on Mars, remain there long enough for the crew to accomplish their mission, and then return to Earth must be significantly larger and more fuel-intensive. It must carry not only fuel for the outbound journey, but also fuel reserves for the return. Where does this fuel come from? On Earth, we have established supply chains, refineries, and launch facilities. But on Mars, in the early days of settlement, there would be none of these things. You cannot simply land on Mars with the expectation that you will manufacture rocket fuel there, at least not initially. The infrastructure required to extract, process, and store such fuel would need to be built first. This is not impossible. The extraction of methane from the Martian atmosphere and the production of oxygen from water ice in the Martian regolith has been studied extensively. But it represents an enormous undertaking, one that would require years of settlement, infrastructure development, and resource extraction before it could support even a single return mission. And then, there is the fundamental problem of crew weight and cargo mass. Every kilogram of humans and equipment that you bring to Mars must be launched from Earth and landed on Mars. This is extraordinarily expensive in terms of energy and resources. A spacecraft that can land 1 ton of cargo on Mars costs billions of dollars to develop and operate. If that ton of cargo includes a human being, along with life support, housing, and supplies, the constraints become even more severe. The economics of the situation align with the physics to create a nearly irresistible conclusion. Once you have brought human beings to Mars at enormous expense and effort, the cost of returning them to Earth, both in economic terms and in terms of the physical resources required, becomes almost prohibitive. It becomes cheaper, easier, and more efficient to send additional supplies to Mars to support those already there than to mount a return mission and bring them home. But there is more to it than mere economics and fuel calculations. There is the question of human adaptation itself. We are creatures shaped by Earth, not merely shaped in the abstract sense that all living things have been shaped by the environments in which they evolved, but shaped in the intimate, cellular, moment-to-moment way that defines what it means to be alive. Every system of our body, our skeletal structure, our cardiovascular system, our vestibular apparatus, our musculature, the very geometry of our organs, has been calibrated over millions of years to function in Earth's gravitational field of 9.8 meters per second squared. We do not notice this constant downward pull. It is as normal to us as air is normal to breathe. But it is the fundamental condition under which human physiology operates. Our hearts pump blood against gravity. Our bones are structured to bear weight against gravity. Our sense of up and down, our balance, our proprioception, our fundamental sense of where our body is in space, all depend on this constant gravitational field. Now imagine leaving Earth and traveling to Mars. The spacecraft you travel in is equipped with artificial gravity, at least in some areas, perhaps a rotating section that uses centrifugal force to simulate the comfort of Earth normal gravity. But this comfort is temporary. You arrive at Mars, and you step out onto a world where the gravitational acceleration is only 38% of what you have known your entire life. It is as if the weight of the world has been lifted from your shoulders. You find that you can leap higher, move more easily, that the effort required to simply exist has been dramatically reduced. At first, this is exhilarating, but your body knows something is wrong. Or rather, your body begins to adapt to an environment it was never designed for. The human skeleton, that magnificent structure of calcium and phosphate, begins to lose bone density in the reduced gravity of Mars. Your muscles, no longer required to move the same mass against the same gravitational pull, begin to atrophy. Your cardiovascular system, which has spent your entire life pushing blood against Earth's gravity, begins to adjust to the reduced demands of Martian gravity. Your vestibular system, that delicate array of fluid-filled tubes in your inner ear that tells you which way is up, begins to recalibrate itself around the new gravitational paradigm. These changes are not instantaneous. They unfold over weeks and months. And here is the critical point. These adaptations, these physiological changes that your body makes to survive in the Martian environment, make you less and less suited to survive in Earth's environment. If, after a few months on Mars, you were to board a spacecraft and return to Earth, you would encounter a world whose gravity felt almost crushing. Your bones, weakened by Martian gravity, would be fragile and prone to fracture. Your muscles, atrophied by months of lower gravity, would struggle to support your weight. Your cardiovascular system would need to readjust to pumping blood against the stronger gravitational pull. You would become, in effect, an invalid, unable to move freely, requiring months of physical therapy and rehabilitation to regain the capacity to simply walk. This is not theoretical. We have data from the astronauts, who have spent months in the microgravity environment of the International Space Station. They return to Earth profoundly deconditioned. Some require assistance simply to walk. It takes months of intensive physical rehabilitation for them to regain normal function. And the International Space Station offers only the faintest taste of what extended adaptation to another gravitational environment would entail. On Mars, the process would be more gradual, but ultimately more profound. If you spent a year on Mars, the minimum duration for an early settlement mission, your body would undergo extensive adaptation. Your bone density might decrease by 10 to 15%. Your muscle mass would decline significantly. Your cardiovascular capacity would diminish. Your eyes would change shape as your body adapted to the new gravitational environment. Even your teeth, those hard structures of enamel and calcium, would begin to be affected by the altered mineral balance in your body. After 2 or 3 years on Mars, a realistic duration for an initial settlement mission, these adaptations would be profound. Your bones would be significantly weaker. Your muscles would be substantially atrophied. Your body would have begun to reshape itself around the Martian environment. You would, in a very real sense, be developing into something suited for Mars rather than Earth. And then, imagine boarding a spacecraft. Imagine enduring 9 months of travel, during which you would experience the jarring transition from Martian gravity to the weightlessness of space, and finally the crushing reacceleration as you approached Earth and began your descent through the atmosphere. Imagine then stepping onto a world whose gravity feels like a physical assault, where you cannot walk without pain, where you are dependent on medical intervention and months of rehabilitation. This is not merely discomfort. This represents a genuine biological transition. The longer you remain on Mars, the less you are biologically equipped to survive the return journey and the Earth environment that awaits you. There is another dimension to this biological transformation as well: the psychological and emotional adjustment. Humans are creatures of place. We form attachments to environment, to community, to the particular landscape and sky that we call home. After months or years on Mars, working with a small community of fellow settlers, dedicated to the enormous task of establishing human presence on another world, the notion of leaving becomes increasingly difficult. This is not weakness or failure of resolve. It is the simple human reality that we become home in the places where we invest ourselves. Let us now consider the broader economic and strategic logic of Mars settlement from the perspective of the institutions and nations that would finance it. A mission to Mars is extraordinarily expensive. Current estimates suggest that a human Mars program, conducted by a wealthy space agency or international consortium, might cost between $500 billion and $1 trillion over the course of 2 or 3 decades. This is not inconsequential money, even for the wealthiest nations and organizations. For context, the entire Apollo program cost roughly $280 billion in today's dollars. A human Mars program would likely exceed Apollo in scope and complexity by a factor of several. Given this immense investment, what is the justification? Why would any rational actor, any government, any space agency, any commercial enterprise, spend such an enormous sum to place human beings on Mars? There are several possible answers. The first is scientific, the desire to understand Mars, to study its geology, its potential for past or present life, to unlock the secrets of planetary formation and evolution. This is a legitimate scientific justification, one that has motivated much of our Mars exploration to date through robotic rovers and orbiters. But for human exploration, the scientific justification, while real, is insufficient to justify the costs involved. A far more comprehensive program of robotic exploration, with rovers and drones and ultimately autonomous factories producing scientific instruments, could accomplish far more science for far less money than a human program. The scientific return on human Mars exploration, relative to the cost, is not particularly favorable. A second justification is strategic and geopolitical. A nation that successfully places humans on Mars, first, will achieve enormous prestige and symbolic power. The feat will demonstrate technological prowess, national capacity, and the ability to accomplish extraordinary things. This was the primary justification for the Apollo program, in the context of Cold War competition with the Soviet Union. A future Mars program might similarly be justified on grounds of national competition and the desire to demonstrate superiority over geopolitical rivals. But a third justification, and perhaps the most important one, is the beginning of human settlement and the ultimate establishment of a multi-planetary civilization. This is the vision that animates many contemporary advocates of Mars exploration. Rather than viewing Mars as merely a destination to visit, to study, and to leave, they view it as a location for permanent human settlement. The goal is not to send astronauts to Mars and bring them home. The goal is to establish the first permanent human communities beyond Earth. And here is where the logic becomes inexorable. If you are going to the enormous trouble and expense of establishing human settlement on Mars, if you are going to develop the infrastructure, the habitat systems, the resource extraction capabilities, the food production facilities necessary to sustain human communities on an alien planet, then it makes no sense to plan for those communities to evacuate and return to Earth. Such communities would be established for permanence. The investment in infrastructure is justified by the long-term presence of the people who will use it. Furthermore, there is an economic logic to keeping people on Mars rather than returning them to Earth. Once settlement infrastructure is in place, habitats, agricultural systems, water extraction facilities, it costs far more to operate a return mission than to simply supply continued settlement. Sending supplies to Mars costs money. Sending supplies to Mars, allowing them to be used, and then mounting a costly return mission to bring people back costs far more. The efficient use of resources suggests that people who arrive on Mars should stay there. Over time, as the settlement grows and becomes self-sufficient, the economics become even more tilted toward permanence. A Mars settlement that can produce most of its own food, water, and fuel from local resources becomes increasingly independent from Earth. At some point, the settlement is not merely cheaper to maintain on Mars, It may become cheaper to keep operating than to attempt a return mission. The institutions that would finance human Mars settlement, governments, space agencies, eventually perhaps commercial corporations, would thus have powerful incentives to establish settlements intended for permanence. And once such settlements are established, their inhabitants would face the reality that return to Earth, rather than being an option held in reserve, is not practically feasible. There is another crucial factor as well: the development of local resource utilization. As the settlement matures, it develops the capacity to extract water from the Martian regolith, to produce methane and oxygen from the Martian atmosphere, and to manufacture many of the supplies it needs locally. These capabilities make the settlement increasingly self-sufficient, but they also make it more closely adapted to Mars. The fuel production facilities, the water extraction systems, the agricultural systems, all are designed for Mars, for Martian gravity, for Martian solar radiation and temperature cycles. A settlement that has invested enormous resources in developing resource utilization capability on Mars is a settlement designed for permanence. It is not a settlement designed with a mind toward evacuation. The very infrastructure that makes long-term settlement possible makes return increasingly obsolete. And so we arrive at a realization that, once articulated, seems almost inevitable. The first human beings to arrive on Mars will spend the remainder of their lives on Mars. They will not return to Earth. They will not see Earth's blue skies. They will not feel Earth's rain. They will not walk in forests or swim in oceans. They will live their entire adult lives on a world of rust and stone, under a butterscotch sky, in the company of a small community of fellow settlers. This is not a tragedy. This is not a failure or misadventure. This is the logical, predictable, indeed almost inevitable consequence of what it means to establish a human settlement on another planet. In fact, one might argue that the notion that the first Mars settlers should expect to return home represents a failure to think through the true implications of what we are attempting. If we send people to Mars, we should send them with the full knowledge and acceptance that they are making a one-way journey. We should acknowledge this reality openly, rather than hiding it behind euphemisms about eventual return missions that are unlikely to materialize. This acknowledgement actually serves an important purpose. It allows us to think clearly about what kind of people should undertake this mission, what they need, how we should support them, and what kind of community they will build. The first Mars settlers will need to be people of extraordinary psychological strength and commitment. They will need to be people who have genuinely and deeply accepted the reality of permanent exile from Earth. This is not something that can be hidden or minimized. It must be confronted directly. But there is something else as well: the realization that this one-way commitment is not unusual or unprecedented in human history. Throughout human history, people have made similar choices. They have left behind their native land, their families, their entire world, to commit themselves to new communities in new lands. The European immigrants who crossed the Atlantic to settle in the Americas often knew they would never return to Europe. The pioneers who traveled westward across North America, establishing communities in the wilderness, were making one-way journeys into unknown territory. The monks and nuns who took vows of religious community were, in a real sense, exiling themselves from secular society. What makes Mars settlement different is not the nature of the commitment, but rather its totality and its finality. It is exile that is absolute, from which return is not merely difficult but physically impossible. But it is not fundamentally different in kind from commitments that humans have made countless times before. And perhaps, in an age when we have become accustomed to mobility, to the ability to travel freely, to maintain close connections across great distances, this kind of absolute commitment represents something deeply human that we have nearly lost. Perhaps it reconnects us with something essential in human nature, the capacity to commit absolutely, to leave everything behind, to dedicate oneself to a cause larger than oneself. Imagine that you are a person who has traveled to Mars. Imagine that the outbound journey, which took 9 months of travel through interplanetary space, has ended. You have descended to the surface. You have emerged from the lander and stood for the first time under the butterscotch sky of Mars, breathing filtered air, your boots on russet sand. The moment is profound beyond words. You are standing on another planet. You are farther from home than any human being has ever been, in terms of actual distance traversed, actual separation from the world of your birth. You are one of a handful of people to have made this journey. You are, in the deepest sense, a pioneer. But in that moment of triumph and historic significance, there is something else you might feel: the awareness of Earth's absence. You have spent your entire life as an inhabitant of Earth. You have never known any world but this one. Your earliest memories are of Earth's sky. Your first experiences of motion and gravity were Earth's gravity. Your family, everyone you have ever loved, everyone who has ever loved you, all are on Earth. Your entire emotional and psychological existence is rooted in that blue-green marble hanging in space somewhere above the horizon of Mars. When you look up at the Martian sky during the day, it is butterscotch, a pale ochre hue caused by suspended dust particles in the thin atmosphere. When you look at the sky at night, you see stars, but they are harder to see than from Earth. The Martian atmosphere, thin though it is, still scatters light slightly. The stars do not have the sharp clarity they possess from Earth. The constellations are still recognizable from Mars, but they are faint, almost ghostly. And somewhere in that sky is Earth. But Earth is too far away to see, even with the naked eye. Even with a telescope, Earth would be just a faint point of light, indistinguishable from other stars and planets. You cannot look up from Mars and see your home world. On Earth, when you looked up at night and saw Mars, you were looking at a world that was exotic, distant, fascinating. But Mars was still part of your world, in a sense. It was part of the same cosmic environment. Now, from Mars, Earth occupies a similar position. It is up there somewhere, but it is beyond your direct perception. This is a profound psychological shift. For the first time in your life, you inhabit a world where Earth is not the fundamental reference point, not the default location, not home in the way that all previous generations of humans have understood home to be. The sun, that fundamental provider of heat and light that has nourished all human life throughout our species' existence, appears noticeably smaller from Mars than from Earth. It is roughly 40% smaller in angular size, because Mars is about 1.5 times farther from the Sun than Earth is. This means that the sunlight on Mars is roughly 43% as intense as sunlight on Earth. Everything is dimmer. Everything is colder. The world you see around you has less light in it than any place on Earth, even on the cloudiest days in the darkest latitudes. As the weeks and months progress, the reality of your situation becomes increasingly apparent. You are not on a brief mission. You are not visiting this world as a tourist or researcher with a predetermined return date. You are settling here. Your habitat systems are being activated and expanded. Additional supplies are being delivered as the Earth-Mars transfer window allows. Slowly, inexorably, the infrastructure of permanent settlement is being built around you. Your world contracts in some ways and expands in others. Your daily life is bounded by the habitat, the artificial environment you and your companions must maintain to survive. You cannot simply step outside. To go out on the Martian surface, you must don a spacesuit. You must check air supply, pressure systems, radiation shielding. You must never go farther than you can safely return to the habitat. You must never take unnecessary risks, because each person is irreplaceable in this small community. In other ways, your world expands enormously. If you are a geologist, you have an entire planetary surface to explore and study. If you are an engineer, you have the overwhelming challenge of building and maintaining the systems that keep you alive. If you are a biologist, you have the opportunity to conduct research that has never been possible, experiments in the gravity and atmospheric composition of another world, searches for any evidence of past or present Martian life. But underlying all of this is the fundamental reality: you will never leave. You will never again feel Earth's rain on your face. You will never again see Earth's blue sky. You will never again swim in Earth's oceans or feel Earth's wind. You will never again visit the places you loved on Earth, never again be in the physical presence of the people you cherished. This realization comes in waves. At first, it may not feel real. You are too occupied with the immediate challenges of adaptation and survival. But as weeks become months and months become years, the reality deepens. Your body adapts to Mars. The Martian settlement becomes your home in a way that Earth is increasingly not. The people around you become your community, your family. The work you are doing becomes the center of your life. And the knowledge grows. You will die here. You will spend your last breath on Mars. Your body will be returned to Mars soil. The atoms that compose you will eventually become part of the Martian landscape. You will become, truly and finally, a citizen of Mars. Mars is, by the standards of Earth's biosphere, extraordinarily hostile to human life. It is not hostile in the way that the depths of the ocean are hostile. It is not crushing or chemically caustic. Rather, it is hostile through privation. It lacks the things that life requires. It is, in essence, a world of absence. The Martian atmosphere is thin, only about 1% as dense as Earth's atmosphere at sea level. It is composed primarily of carbon dioxide, with trace amounts of nitrogen, argon, and other gases. There is virtually no free oxygen. A human being cannot breathe Martian air any more than they could breathe the vacuum of space. The atmospheric pressure is so low that liquid water cannot exist on the surface. If you exposed water to the Martian atmosphere, it would boil away, even at extremely cold temperatures. The surface temperature varies between roughly -195 degrees Celsius at the poles and -60 degrees Celsius at the equator during summer. These temperatures are far below what any unprotected human could survive. At such temperatures, exposed skin would freeze within minutes. Breath would crystallize. The Martian surface is bombarded with ultraviolet radiation. Earth's magnetic field and thick atmosphere protect us from much of this radiation, but Mars has only a thin atmosphere and no global magnetic field. The radiation at the Martian surface is roughly 100 times more intense than at Earth's surface. Over time, this radiation causes mutations and can damage living tissue. The radiation is one of the most significant health challenges for Martian colonists, requiring substantial shielding in habitats and potentially causing long-term health consequences even with protection. The Martian landscape is dominated by dust, extremely fine particles of iron oxide and silicates. This dust is electrostatically charged, causing it to cling to surfaces and penetrate into mechanical systems. It is fine enough to penetrate into electronics and clog filters. It would be a constant maintenance challenge, requiring careful protocols to manage the intrusion of Martian dust into habitats and equipment. The gravity on Mars is only 38% of Earth's gravity. This has been discussed already in terms of its physiological effects, but it also affects every aspect of daily life. Objects weigh much less. Movement is easier but must be carefully controlled. A person who moved too quickly in Martian gravity might find themselves unable to stop or control their trajectory. The low gravity affects the performance of mechanical systems, the behavior of fluids, the effectiveness of certain types of equipment designed for Earth. Given these conditions, every human being on Mars would need to spend essentially all their time in specially designed habitats that protect them from the environment. These habitats must maintain Earth's normal atmospheric pressure and composition. They must be insulated against the cold. They must have radiation shielding. They must include systems for generating oxygen, managing water, controlling temperature and humidity, removing carbon dioxide from the air. The construction of these habitats is not a trivial undertaking. Early Mars habitats would likely be modular structures, sections that are manufactured on Earth and then transported to Mars and assembled on site. These habitats would need to be designed for extreme durability, as repairs would need to be conducted by the colony itself, without possibility of parts or expert help being sent from Earth. They would need to be sealed environments, with airlocks for entering and exiting to prevent the external Martian atmosphere from entering the habitats. Inside these habitats, life would follow patterns that would be strikingly constrained compared to life on Earth. There would be no going outside casually. There would be no wandering. Every excursion on the Martian surface would require donning a spacesuit, a complex piece of equipment with limited life support duration. A mission on the surface might last several hours at most, and would require careful planning and safety protocols. Food production on Mars would depend initially on supplies brought from Earth. But as the settlement matured, it would develop agricultural systems, pressurized greenhouses where food crops could be grown in Martian soil, enriched with nutrients brought from Earth or extracted locally. The gravity and light conditions on Mars are different enough from Earth that these agricultural systems would need to be specially designed and carefully monitored. The crops grown would be the same species grown on Earth. Mars would not support Martian native agriculture because there is no Martian agriculture, but the conditions would need to be carefully controlled. Water, essential for all life processes, would need to be extracted from Martian ice deposits and regolith. The technology for this has been studied extensively. It would involve melting ice and conducting chemical processes to extract water. The water would then need to be carefully managed, recycled as much as possible to minimize waste, as extracting new water requires substantial energy and effort. Energy to power all of these systems would come from solar panels during the day, supplemented by thermal storage or battery systems to provide power during the long Martian nights. Alternatively, a nuclear reactor might be used, providing more reliable power, but introducing its own complexities and risks. All of this infrastructure, the habitats, the greenhouses, the water extraction systems, the power generation, the communication systems linking Mars to Earth, would need to be maintained constantly by the residents. There would be no calling in a repair person. There would be no shipping something away to be fixed. Every system would need to be maintained and repaired by people on Mars, using parts and materials available on Mars, relying on knowledge and expertise available within the colony. This is not impossible. Humans are remarkably capable of solving practical problems and maintaining complex systems. But it represents a level of self-sufficiency and technical competence that would need to be built into the colony from the beginning. Every colonist would need to have broad technical knowledge and the capacity to troubleshoot and repair complex systems. There would be no specialists who knew only one area. Every person would need to be something of a generalist, capable of contributing to multiple aspects of the settlement's survival and maintenance. The material world would be constrained in ways that are difficult for contemporary humans to imagine. You would wear the same clothing as your companions. Clothing would be manufactured from fabrics brought from Earth or, eventually, synthesized from materials produced on Mars. Every object in your environment would be something that someone brought from Earth or manufactured on Mars from local materials. There would be no shopping, no consumer choice, no ability to simply purchase something you needed. You would have what was available, or you would go without. The social environment would be equally constrained. Your community would consist of the other colonists, perhaps a few dozen in the early days, eventually perhaps a few hundred. You would spend nearly all your time with these people. You would work with them, eat with them, sleep in close proximity to them, depend on them for your survival. There would be no ability to leave, no possibility of taking a vacation, no chance to visit family or friends or different communities. You would be bound to your community in a way that modern humans have largely escaped. This level of constraint and isolation is not something that contemporary people are generally accustomed to. Modern life is characterized by mobility, by choice, by the ability to move between communities and social groups. Mars settlement would represent a return to a different mode of human existence, more bounded, more local, more communal, more focused on the immediate group and the immediate environment. Whether this would be experienced as oppressive or liberating might depend very much on the psychology and temperament of the individual. For some, the constraint would feel like imprisonment. For others, it might feel like belonging to something larger than oneself, like participating in a fundamental human project that justified the sacrifice of individual mobility and choice. Let us imagine the passage of time on Mars. Let us imagine the arc of a human life lived under Martian skies, devoted to the project of maintaining and expanding a human settlement on an alien world. A person arrives at Mars in the early 30s, in excellent physical condition, with the psychological resilience and technical expertise deemed necessary for such a mission. Their first weeks and months are consumed with immediate tasks, activating habitat systems, conducting scientific surveys, beginning the work of establishing agricultural systems, learning the specific demands and rhythms of Martian existence. In the early months, the person maintains regular communication with Earth. They send messages, not real-time conversations, because radio signals take between 3 and 22 minutes to travel between Earth and Mars, depending on the relative positions of the planets. The delay is long enough to make real-time conversation impossible. But they send messages to family and friends on Earth. They share their experiences, their discoveries, their emotional experiences of being on another planet. For the first few months, this communication feels like an important connection to home. But as time passes, something shifts. The people on Earth are moving forward with their lives. Seasons change on Earth. People are born and die. Political situations evolve. New technologies emerge. The world continues to develop in ways that the Martian colonists cannot influence or fully participate in. The messages from Earth begin to feel slightly alien, describing a world that is becoming increasingly distant and unfamiliar. Meanwhile, the Martian settlement is becoming increasingly familiar. The particular challenges of maintaining the habitats are becoming routine. The faces of fellow colonists are becoming more recognizable than any face on Earth. The rhythms of Martian days and nights, which are nearly the same length as Earth days, as it happens, become the rhythm of the colonists' life. A year passes. Then 2 years. The initial team of colonists are joined by additional crews in subsequent transfer windows. The settlement grows. New habitats are established. Agricultural systems expand. A small but growing community of humans is taking root on Mars. As the years accumulate, something profound happens. The person who arrived as an astronaut, as a representative of Earth, begins to become a Martian. This is not a matter of biology. They are still physiologically human, still adapted to Earth. But it is a matter of identity, of belonging, of where one places oneself in the cosmos. Family on Earth grows older. Parents age. Siblings have children. The colonist on Mars receives news of these events through messages that take minutes to deliver. They receive images and videos, but they cannot participate. They cannot hold a newborn nephew. They cannot visit an ailing parent. They cannot attend funerals. The emotional connections that define so much of their Earth existence gradually attenuate, become more distant, become something remembered rather than something lived. After 5 years on Mars, the colonist has spent more than 5,000 consecutive days on another planet. That is longer than most people spend in a single job, longer than many people spend in a single home. It is long enough to develop deep roots, to learn the landscape in intimate detail, to become part of the community in a fundamental way. The possibility of return, if it ever seemed real, has long since passed. Return would require a spacecraft designed for that purpose. It would require a journey of 9 months, during which the colonists would experience both the absence of Martian gravity and the presence of microgravity, a potentially dangerous physiological challenge. It would require arriving at an Earth whose gravity, after 5 years of Martian adaptation, would feel crushing and painful. And honestly, by the 5-year mark, would return even be desirable? The colonists' life on Mars has become their real life. The memory of Earth is increasingly like a dream, vivid in some moments, but slipping away, becoming less immediate, less present. After 10 years, the colonist is in their mid-40s. They have spent a full third of their adult life on Mars. Their bones bear the marks of Martian gravity. They are less dense than they would have been on Earth, adapted to a world with 38% of Earth's gravity. Their muscles are different, developed to operate efficiently in lower gravity. Their eyes have adapted to the dimmer light. Every cell in their body has been shaped by the Martian environment. They have spent this decade engaged in meaningful work. They have conducted scientific research that has advanced human understanding of planetary science. They have contributed to agricultural systems that sustain the growing settlement. They have trained newer colonists in the skills needed to survive and thrive on Mars. They have participated in expanding human presence on another world. This is not wasted time. This is not time spent in exile or punishment. This is time spent in dedication to something larger than themselves. After 15 years, after 20 years, the colonist is no longer the same person who arrived. They have been shaped by Mars, and by the community they have built there. They have become, in every meaningful sense, a Martian. And when the colonist eventually dies, whether from accident, illness, or simply the gradual aging of their body, they will be buried in Martian soil. Their atoms will become part of the Martian landscape. In the most literal sense, they will become part of Mars, integrated into that alien world, their bodies recycled into the soil and atmosphere and geological structures of the planet. This is not a tragedy. It is the natural end of a human life lived in commitment to a place and a community. It echoes what happens to human bodies everywhere. We return to soil, become part of the landscape, our atoms recycled into new life. On Earth, this is simply the ordinary fate of all living things. On Mars, it will be the same. As the settlement grows, something more develops than simply a community focused on survival. A culture begins to form. The colonists develop ways of marking time, ways of celebrating, ways of creating meaning and expressing identity. The Martian year is 687 Earth days long. A Martian day, a sol, is about 24 hours and 37 minutes long. The colonists would naturally shift toward using Martian time. A new timekeeping system would develop, with 24-hour days and a calendar based on Martian years. The settlement might mark the anniversary of the first human arrival on Mars as a significant date, something like a founding day or Independence Day, a moment worthy of celebration and reflection. The colonists would develop stories about their world. They would give names to geographical features, craters, mountains, valleys, canyons. These names might be drawn from various cultural traditions, or might be new names created specifically for Mars. They would develop language and terminology specific to their environment and their work. Some of these terms might be borrowed from other languages, but some would be new, created specifically to describe the unique experiences and challenges of Martian life. As the settlement expands and becomes more secure, artistic and cultural expression would emerge. The colonists would create art, write literature, create music, make films. This art would be shaped by their unique environment and perspective. The Martian landscape, with its rust-colored deserts and pink skies, would inspire visual artists. The experience of living on another world would inspire writers and philosophers. Musicians would create works that reflected the Martian experience, the longing for Earth, the commitment to a new world. Over multiple generations, as children are born on Mars to the original colonists, a uniquely Martian culture would develop. These children would not be exiles from Earth. They would be natives of Mars. For them, Mars would not be a destination they traveled to and chose to remain on. It would simply be home, the only world they had ever known. They would not share the psychological experience of the original colonists, the memory of Earth, the sense of separation from a native world. This would create an interesting generational dynamic. The original colonists would carry with them the memory of Earth, the understanding of Earth's oceans and forests and open skies. But each new generation born on Mars would be slightly more Martian and slightly less Earth-human. By the third or fourth generation, most of the population would consist of people who had never been to Earth, who had only abstract or learned knowledge of what Earth's natural environment was like. These later generations might view the original colonists' stories about Earth with something like the way we view historical stories about distant ancestors' homelands. Earth would be important, the origin point of human culture, the place where all of human history before Mars had occurred. But it would be a place known only through stories, images, and transmitted culture, not through lived experience. The culture of Mars would naturally develop differently from Earth's cultures. It would be shaped by the specific environment, by the gravity and light conditions, by the necessity for cooperation and mutual dependence, by the psychological reality of living as a small community on an alien world. Over generations, this might develop into something genuinely new, a Martian culture, distinct from Earth's cultures, reflecting the unique circumstances of existence on Mars. This raises interesting questions about identity and belonging. Would the Martian colonists and their descendants consider themselves exiles from Earth, or would they be pioneers of a new world? Would their relationship to Earth be one of separation and loss, or would it be one of connection to a homeland from which they had chosen to depart? The answer might be different for different individuals. Some would maintain a strong connection to Earth, viewing Mars as home in practicality, but Earth as home in emotional and spiritual truth. Others might more fully embrace Martian identity, viewing Earth as a historical source, but not as a place of belonging. Over generations, as those born on Earth became fewer and fewer, the question might cease to be as pressing. Mars would simply be home, the planet where humans lived, the place where human civilization had established one of its centers. Having painted a picture of what life on Mars might be like, we must pause to consider the ethical dimensions of sending human beings on a one-way mission, knowing that they will never return to Earth. This raises profound moral questions. Are we treating these colonists fairly by asking them to commit to permanent exile? Are we being honest with them about what they are volunteering for? What obligations do we have to support them, to provide for their welfare, to ensure that their sacrifice is honored? One perspective is that voluntary one-way missions, if properly conducted, are ethically defensible. The colonists would be volunteers, not conscripts. They would be carefully screened to ensure they understand and accept what they are committing to. They would be thoroughly informed about the permanent nature of the mission. Assuming they meet these criteria, they would be making an informed choice, and we would have no more ethical obligation to provide return capability than we do to provide return capability for any other choice a person makes to leave their homeland. After all, when people immigrate to a new country, they are often making a choice that effectively separates them from their homeland. They may intend to return someday, but they may also end up spending their entire lives in their adopted home. We do not consider this unethical, as long as the choice is made freely and with informed understanding. But there is something different about Mars that might complicate this analogy. The difference lies in the totality of the separation and the inability to change one's mind. If an immigrant to a new country finds they have made a mistake, they can, in principle, return to their homeland. It may be difficult, it may be painful, but it is possible. For a Mars colonist, this is not possible. Once you are on Mars, you are on Mars for life. There is no possibility of return, no ability to go home if the experience is more difficult than you anticipated. This might suggest a higher ethical burden on those recruiting colonists. It suggests that the screening process needs to be extraordinarily rigorous. It suggests that psychological support systems need to be comprehensive and ongoing. It suggests that the living conditions and community support on Mars need to be substantial enough to ensure that colonists can maintain psychological well-being and find meaning in their experience. Another ethical consideration concerns the obligations of Earth to the Mars colony. Once human beings have established themselves on Mars, they become part of human civilization. They depend for their survival on continued support from Earth, supplies, replacement parts, new recruits joining the colony. This creates a relationship of dependency that could potentially be exploited or broken. What happens if, for some reason, Earth decides to end support for the Mars colony? What if there is a catastrophic failure in support systems, leaving the Martians without the supplies they need? The colonists would be vulnerable in a way that terrestrial communities are not. They cannot rely on the local environment to sustain them indefinitely. They must receive support from Earth. This suggests that there are significant ethical obligations associated with establishing human settlement on Mars. There is an obligation to maintain support once settlement has begun. There is an obligation to provide the colonists with the resources needed for a decent quality of life, not merely survival. There is an obligation to maintain communication and cultural connection between Earth and Mars. There is an obligation to honor the sacrifice that the colonists are making. These obligations are not insignificant. They would require substantial ongoing commitment from Earth's institutions and populations. They would require dedicating significant resources to supporting Mars settlements, even after the initial exploration phase is complete. In an era when many people on Earth face hardship and deprivation, one might reasonably question whether the commitment to support Mars settlements is ethically justified. One response to this concern is to note that the long-term survival of human civilization depends on becoming a multiplanetary species. In the long run, Having human communities on multiple planets makes the entire human species more resilient to catastrophic events. It also provides opportunities for scientific research, resource development, and expansion of human culture and achievement. These long-term benefits might justify the present commitment of resources to establishing Mars settlements. But this is a claim about long-term benefit, not a claim about present ethics. In the present moment, dedicating resources to Mars settlement when some people on Earth lack access to clean water or basic medical care might seem difficult to justify. Perhaps the answer is that both things can be true. We can work to address human suffering on Earth, to ensure that all people have access to basic necessities and opportunities for flourishing. And we can simultaneously work toward establishing human settlement on Mars, as part of our long-term vision for human civilization. These are not mutually exclusive goals. They require different approaches and resources, and there is room for pursuing both. Philosophers and poets have long explored the question of what home means. Home is not merely a location, it is a place of belonging, a place where one's identity is rooted, a place where one can be oneself. For the Mars colonists, the question of home becomes complicated. They left a home on Earth, a specific place, specific people, a specific landscape and culture that shaped who they were. In leaving, they did not merely leave a location. They left the totality of what home had been for them. On Mars, they would build a new home. They would create habitat, community, culture, meaningful work. They would develop attachments to people and places on Mars. The Martian settlement would become home in the sense that it is where they live, where their community is, where their daily life is centered. But for the original colonists, at least, there might always be a quality of homesickness, a longing for Earth, a sense of something lost, an awareness that they are living in exile even if it is voluntary exile in service to something meaningful. This longing might fade over time. As years pass, as attachment to Mars deepens, as the memory of Earth becomes increasingly distant, the colonists might find that Mars becomes their true home, and Earth becomes something like a place of origin rather than a place of belonging. For their children, people born on Mars, the question is different. Mars is simply home. Earth is a place from which their parents or ancestors came, but not a place where they were born or raised. Earth might be important to them in the way that the country of one's ancestors might be important to a contemporary immigrant, but it would not have the same weight of lived experience. This transformation, the way that Mars gradually becomes home for successive generations, might be one of the most significant cultural and psychological transformations in human history. It would represent a fundamental shift in where human beings place themselves in the cosmos. It would represent the emergence of multiple centers of human civilization, no longer all rooted in a single planetary home. For some, this might feel like loss, the end of Earth as the undivided center of human existence. But it might also feel like gain, the expansion of human civilization, the emergence of new centers of culture and achievement, the diversification of human life and experience across multiple worlds. The Mars colonists, in accepting the reality that they will never return to Earth, might be participating in something larger than themselves. They might be participating in the transformation of human civilization from a single-planet species to a multi-planet species. They might be the foundation upon which human futures, plural, are built. The universe is almost incomprehensibly large. The nearest star to our Sun, Proxima Centauri, is about 4.2 light-years away. A light-year is the distance that light travels in 1 year, roughly 9.5 trillion kilometers. So the nearest star is about 40 trillion kilometers away. At the fastest speeds that human-made spacecraft have achieved, a journey to Proxima Centauri would take about 100,000 years. This is not hyperbole. The distances between stars are so vast that our normal intuitions about distance break down. We are accustomed to thinking about distances in terms of kilometers, or at most, millions of kilometers. But the distances between stars are measured in light years, in the distance that light, the fastest thing we know of, travels in a year. Earth and Mars are close neighbors in the context of the solar system. A journey between them takes months, not years. We can imagine establishing communication and regular supply shipments between the two planets. The distances, while vast by terrestrial standards, are manageable by the standards of space travel. But this close relationship is peculiar to the Earth-Mars system. Mars is unusual among the planets in being close enough to Earth and pleasant enough, by the standards of planets, that human settlement is even conceivable. Venus is hellish, a world of crushing atmospheric pressure and temperatures hot enough to melt lead, caused by a runaway greenhouse effect. Mercury is extremely hot on the sun-facing side, and extremely cold on the night side, and has virtually no atmosphere. The outer planets are distant, cold, and lack solid surfaces where humans could stand. The moons of the outer planets are interesting from a scientific perspective and might eventually host research stations, but are far more distant and difficult to support than Mars. Given the constraints of physics and chemistry, Mars is the one planet in our solar system where human settlement is reasonably conceivable in the foreseeable future. But Earth and Mars will not always remain in this relationship of relative proximity. The solar system is not static. The planets move in their orbits, but they also gradually evolve due to the effects of tidal forces, gravitational interactions, and other long-term dynamical effects. Over millions of years, planetary orbits can change. Over billions of years, the changes can be dramatic. Furthermore, the Sun itself is evolving. It is currently in the main sequence phase of its life, the phase where it is stably fusing hydrogen in its core. But this phase is temporary. The Sun is currently about 4.6 billion years old, and is expected to continue burning hydrogen for another few billion years before it expands into a red giant. A red giant sun would be radically different from the Sun we know. It would be larger and brighter. Its surface would extend outward, potentially engulfing the inner planets. Earth would become uninhabitable, and likely would be consumed entirely. Mars, being farther from the Sun, would fare better. It might remain in the habitable zone, the region where temperatures are compatible with liquid water, even as the Sun's brightness increased and its size expanded. In this long-term cosmic perspective, Mars might eventually become more habitable than Earth. In the far future, if humanity survives that long, Mars might become the center of human civilization, with Earth either lifeless and abandoned or simply a historically important origin point, the way that Africa is the origin point of modern human civilization, but not where most humans live. This long-term perspective sheds light on why Mars settlement might be important. Establishing human presence on Mars is, in a sense, a step toward the long-term survival of the human species. If humanity becomes permanently established on multiple planets, then no single planetary catastrophe can eliminate the entire species. A meteor impact, a supervolcanic eruption, a pandemic, a nuclear war, any of these could potentially be catastrophic for human civilization on Earth. But if humanity is established on Mars as well, such catastrophes would not represent the end of human civilization altogether. From this perspective, the first Mars colonists are not merely explorers or scientists. They are participants in a project of species survival and diversification that unfolds across geological timescales. Humans are exploring creatures. Throughout our history, we have been driven to move beyond the known world, to travel to distant places, to encounter new peoples and new landscapes. This exploratory impulse has been central to human culture and psychology. In the ancient world, explorers traveled to distant lands, across deserts, across mountains, across oceans. These journeys were often dangerous. Many explorers did not return, but they expanded human knowledge of the world and enabled the development of trade networks and cultural exchange across vast distances. In the age of exploration, from the 15th century onward, European explorers traveled across the world's oceans to Africa, Asia, and the Americas. These voyages were driven by multiple motivations: the desire to find new trade routes, the spread of religious belief, the accumulation of knowledge, and yes, the desire for conquest and exploitation. The consequences of this age of exploration were morally complex. They brought cultural exchange and technological innovation, but also colonialism, slavery, and the devastation of indigenous peoples. In more recent centuries, exploration has taken new forms. Explorers have traveled to the poles, scaled the highest mountains, descended to the deepest ocean trenches. And in the 20th century, exploration reached into space. Humans have traveled beyond Earth's atmosphere, landed on the moon, and established permanent human presence in low Earth orbit through the International Space Station. Mars represents the next frontier in human exploration. It is the natural destination beyond the moon, a planet that is sufficiently large and close that human settlement is conceivable, yet sufficiently distant and challenging that reaching it represents a genuine achievement. But Mars settlement is different in character from the exploration that came before. When humans explored Earth, they were exploring a world where, if they ventured far enough, they could find other humans. They could find indigenous peoples, trade partners, competitors. The world was large but finite. It contained multiple human societies. When humans go to Mars, they are going to a world that is, at least initially, entirely uninhabited by intelligent beings. Mars is a dead world in terms of intelligent life. There may or may not be microorganisms on Mars. This is one of the major scientific questions that Martian exploration will help answer. But there are certainly no intelligent Martian beings to encounter, no Martian societies to trade with or compete with. This makes Mars settlement fundamentally different from exploration on Earth. On Earth, exploration led to encounter with other peoples. On Mars, exploration leads to the creation of human settlements in an empty landscape. The settlement is not an encounter with another civilization, but the extension of human civilization to a new world. This raises ethical questions that are different from the ethical questions of terrestrial exploration. In terrestrial exploration, the primary ethical question was how to treat indigenous peoples and their lands. In Mars settlement, the primary ethical question is different. It is how to establish human civilization on another world while maintaining respect for the scientific study of that world and ensuring that the establishment of human settlement does not interfere with the search for evidence of past or present Martian life. One of the most profound dimensions of human Mars settlement would be its recovery of a particular kind of human experience that has become rare in our modern world: the direct encounter with the alien and the genuinely new. For most contemporary humans, the world has become thoroughly mapped and explored. We can access images from every part of Earth through satellite photography and the Internet. We can see the precise location of any place on Earth through Google Maps. We can watch videos from the deepest ocean trenches and the highest mountain peaks. The planet Earth is known to us in extraordinary detail. This is wonderful in many ways. It has expanded human knowledge and enabled us to understand the world more comprehensively than any previous generation. But it has also, in a subtle way, diminished a particular kind of human experience. The experience of encountering something genuinely unknown, genuinely alien, something that we cannot understand by reference to previous experience. When the first humans to arrive at Mars step out of their landing craft and look around at the Martian landscape, they will be experiencing something that no other human has ever experienced. They will see a landscape that is genuinely alien, rock formations that follow no patterns they have seen on Earth, a sky of unfamiliar color, a light that is strange and dim, a horizon that curves differently than Earth's horizon. Even though Mars has been extensively photographed by robotic rovers and orbiters, those photographs cannot convey the full reality of standing on Martian soil and looking around at the landscape. There are dimensions of experience that can only be had through direct presence. The particular quality of light, the apparent depth and scale of the landscape, the feeling of the ground beneath one's feet, the particular way that the horizon appears when you are standing on it rather than looking at a photograph of it, all of these would be novel experiences. This recovery of wonder, the direct encounter with the genuinely alien, is itself a valuable aspect of human Mars settlement. It reconnects us with a mode of human experience that has become rare in our heavily mapped world. It gives us a direct experience of the universe beyond Earth, a direct confirmation that there are worlds other than the one we were born on, that the universe contains landscapes and environments that are genuinely different from anything we know. For the colonists themselves, this would be a profound psychological and spiritual experience. They would be not merely exploring an alien world but inhabiting it, developing an intimate familiarity with its landscape and environment. They would watch Martian sunsets, which are reported, based on rover photography, to have a blue tint opposite to the orange sunsets on Earth, due to the way that the Martian atmosphere scatters light. They would watch dust storms rise over the horizon. They would conduct geological surveys that gradually revealed the history of Mars, the processes that shaped its landscape, the evidence of whether life ever emerged on this world. And they would do all this from the perspective of inhabitants, not merely visitors. They would not be camping on Mars and waiting to return home. They would be making Mars their home, settling into it, becoming residents of it in the deepest sense. Perhaps the deepest question raised by Mars settlement is, what does it mean? What is the significance of human beings establishing permanent settlements on other planets? What does it tell us about ourselves and our place in the universe? One perspective is to view Mars settlement in terms of human achievement and dominion. We are capable beings, ingenious and creative. We have developed the technology to travel to other planets and establish habitats there. Mars settlement represents the triumph of human capability, the expansion of human dominion beyond our native planet, the conquest of another world. But this perspective might be incomplete or even misleading. Mars is not a world to be conquered. It is a world to be inhabited, to be understood, to be respected. The work of Mars settlement would not be the work of dominating and exploiting Mars, but of living in harmony with Martian conditions, developing sustainable ways of existing on that world, maintaining scientific study of the Martian environment. Another perspective is to view Mars settlement in terms of human survival and species continuation. The establishment of permanent human settlements on multiple planets makes humanity more resilient and more likely to survive long term. This perspective emphasizes the pragmatic benefits of Mars settlement, the insurance policy it provides against extinction-level catastrophes. But perhaps the deepest significance of Mars settlement lies elsewhere. Perhaps it lies in the way that Mars settlement expresses something fundamental about human nature, our drive to explore, to understand, to extend ourselves beyond the boundaries we have always known. It expresses our refusal to accept the world as given, our determination to ask what else might be possible, our willingness to sacrifice in service to visions of futures that might benefit people we will never meet. The first Mars colonists would be, in a very real sense, making a sacrifice for future generations. They would be spending their lives in a harsh, constrained environment, separated from Earth and the people they loved, engaged in the difficult work of establishing human presence on another world. They would do this not because it would directly benefit them, but because they believed it was important for human civilization, for human knowledge, for human future. This kind of sacrifice is not common in contemporary secular societies. We are accustomed to thinking of individual benefit and personal fulfillment as the primary motivators of human action. But humans are also capable of being motivated by larger causes, by commitments to things beyond themselves, by the willingness to sacrifice for something they believe is important. The Mars colonists would be expressing this capacity for transcendent commitment. They would be saying, "There is something more important than my comfort, my safety, my ability to return home. There is something more important than my personal happiness. There is the expansion of human civilization, the achievement of human potential, the establishment of our species on multiple worlds. I will sacrifice my own ease and my own freedom of return in service to this larger goal." This is a particular kind of nobility, not the nobility of conquest or dominion, but the nobility of service to something beyond oneself. It echoes the nobility of religious communities, of scientific pioneers, of those who have dedicated themselves to serving others or pursuing knowledge or achieving important goals at great personal cost. Let us project ourselves forward in time. It is now 50 years since the first humans arrived at Mars. The early, small settlement of a few dozen people has grown into a thriving community of several thousand. There are now 4 separate settlements in different locations, each with distinct environments and research focuses. The original settlement, at the site of the first landing, has become something like a historical monument, preserved in something like its original form, a reminder of those first days when humans first dared to establish themselves on another world. The Martian settlements have become increasingly self-sufficient. Agricultural systems that were carefully tended in their early years have matured into something more stable and productive. Hydroponics facilities and underground greenhouses produce much of the food that the settlements consume. Water is extracted routinely from ice deposits. The production of methane and oxygen from the Martian atmosphere has been optimized, and several settlements now produce their own fuel, reducing dependence on supply shipments from Earth. But the settlements are not fully independent. They still depend on Earth for certain critical supplies, rare earth minerals, replacement parts for highly specialized equipment, certain medications, and technological components that are too complex to manufacture on Mars. Spacecraft still depart Earth every 26 months during the Earth-Mars transfer window, bringing supplies and new residents. The population of Mars includes now the second and early third generations born on Mars. These people have never been to Earth. For them, Mars is not a destination but a home. They speak with knowledge of Earth. They have learned about it in school, seen images and videos, read about its history, but they have no lived experience of Earth. The concept of Earth's oceans and forests and open skies is something they understand abstractly, as one might understand the concept of a distant country described in books, but not something they have experienced directly. The culture of Mars has matured. There is a calendar that tracks both Earth dates and Mars dates, but increasingly, the Mars dates are the ones that matter to daily life. There are holidays and celebrations specific to Mars culture, the anniversaries of important events in Mars history, the discoveries that have changed understanding of Mars, the cultural and artistic achievements of the Martian community. The architecture of the settlements has matured as well. The early habitats, which were relatively simple modular structures, have been expanded, modified, and evolved. Some of the early structures have been preserved as historical monuments, while new, larger structures have been built alongside them. The settlements now include not just habitats and laboratories, but also civic spaces, areas where the community can gather, where cultural events can take place, where people can experience something beyond the purely functional. The landscape around the settlements has been modified by human presence. There are roads, not highways, but paths worn by countless trips of rovers and equipment. There are antenna arrays for communication with Earth and for receiving satellite data about Mars. There are solar panels and wind turbines for power generation. The Martian landscape has been marred by human presence in subtle but unmistakable ways. The science being conducted on Mars has become increasingly sophisticated. The original goal, simply to understand Mars, to learn whether it ever harbored life, to characterize its geology and environment, continues. But there are also deeper scientific questions being pursued. The settlements are conducting experiments impossible to do on Earth, taking advantage of Martian gravity and the unique properties of the Martian environment. They are making discoveries about planetary formation, about the evolution of Mars, about the possibilities for life to emerge on worlds different from Earth. And they are searching. The question of whether Mars ever harbored life, whether microbial organisms ever emerged in Martian water and soil, continues to drive scientific research. Deep drilling has been conducted, bringing samples from kilometers below the Martian surface where subsurface life, if it existed, might have persisted longer against the radiation and cold of the surface. The evidence is suggestive but inconclusive. The presence of water, the presence of chemical energy sources, the chemical complexity of Martian soil, all suggest that life might have emerged. But definitive evidence remains elusive. For the people who arrived on Mars during the first years of settlement, there is now more than a generation of distance between their departure from Earth and the present moment. Many of them are now elderly, or have already passed away. The generation that remembers Earth directly is becoming smaller, less influential, moving gradually into the historical past. This represents a profound psychological shift. The Mars settlements have transitioned from being communities of people who chose to leave Earth, who understand themselves as exiles or pioneers seeking to establish a beachhead on an alien world. They have become communities with their own generational depth, their own people who were born there, their own historical continuity extending back decades. This creates a different psychological relationship to Earth. For the original colonists, Earth remains home in the deepest sense. Even if they never return, Earth is the place where their formative years were spent, where their families originated, where their most basic sense of identity was formed. There is a homesickness that, even if it becomes manageable or even fades, never entirely disappears. There is a quality of exiling in their experience. For those born on Mars, Earth is different. It is not home in the way Mars is home, the place where they wake, where they work, where their community is. Earth is the place where humanity comes from, where their ancestors lived, where the majority of human civilization still centers. It is important and worthy of respect and connection, but it is not home. It is the place of origin, not the place of belonging. This shift in psychological orientation is significant. It suggests that, over time, the Mars settlements would develop psychological and cultural independence from Earth. The original colonists are the bridge, people who remember Earth directly and maintain connection to it, but who are also dedicated to Mars. Their children and grandchildren are becoming fully Martian, with Earth as heritage rather than home. This might cause some friction or sadness among the original colonists. The realization that the next generation does not experience Earth as home, does not long for Earth as they do, does not maintain the same connection to the world of their birth. But it is also the natural evolution of settlement. Every new settlement eventually develops its own identity, distinct from the origin point. The children of immigrants are never quite the same as their immigrant parents. They are more fully of the new place, less marked by the old place. Over more generations, this process continues. By the time a century has passed since the first settlement, the dominant population of Mars consists of people for whom Mars has always been home, whose ancestors arrived generations ago, whose identity is rooted in Martian history and culture rather than Earth history and culture. At some point in this process, the Mars settlements might become effectively independent. They might produce most of their own goods, grow most of their own food, manufacture most of their own equipment. Their dependence on Earth might diminish to a level where regular supply shipments are not absolutely necessary. At that point, the Earth-Mars relationship might shift from one of dependency and support to one of trade and exchange between two communities. Even more profoundly, the Mars settlements might develop sufficient capability to send expeditions to other locations in the solar system. If humans can establish settlements on Mars, they might eventually extend to the moons of Jupiter and Saturn, to the asteroid belt, to Venus. The Mars settlements might become themselves the origin point for further expansion. What might the solar system look like 200 years from now? 500 years from now? 1,000 years from now, if human civilization continues and expands? It is impossible to predict with confidence, but we can imagine possibilities. In 200 years, the Mars settlements have grown to encompass tens of thousands of people across multiple regions. Scientific research has progressed far beyond what we can currently imagine. The question of past or present Martian life has been definitively answered through deep investigation of the planet. Additional settlements have been established on the Moon, on the moons of Mars, on asteroids in the asteroid belt. The solar system has become something like the ocean in the age of exploration, containing multiple human settlements, each with distinct communities and cultures, trading with each other, exploring further reaches. In 500 years, human settlements exist on multiple planets and moons throughout the solar system. A person born on Mars might travel to Europa, a moon of Jupiter, in the same way that a person in contemporary Earth might travel to a different continent. The question of whether life emerges on other worlds has been answered, at least for the planets and moons of our solar system. Scientific knowledge of planetary science, of the possibilities for life, of the formation of worlds, has expanded enormously. In 1,000 years, if human civilization has continued to develop and expand, the solar system has become a genuinely multi-centered civilization. Humans have established settlements on dozens of worlds. New technologies, perhaps including some form of faster-than-light travel, or perhaps some other development we cannot currently imagine, might have enabled exploration beyond the solar system. Or alternatively, something might have happened to dramatically alter or end this expansion. A catastrophe on Earth might have devastated human civilization. A meteor impact might have caused extinction. Or, less dramatically, the focus of human civilization might have shifted. Perhaps humans decide that the expansion into space, while interesting, is not a priority, and instead focus on other goals and problems. We cannot know which of these futures will actually come to pass. But the point is that, by establishing permanent human settlements on Mars and beyond, we open possibilities that would otherwise be closed. We create new branches on the tree of human future, new ways that human civilization might develop. And the first Mars colonists, accepting that they will never return to Earth, are in a real sense the creators of these possibilities. They are not living merely for themselves, but for the futures that might be built on the foundation they establish. As Mars settlements mature and expand, new ethical questions emerge, different from the questions that faced the earliest colonists. When there are only a few dozen people on Mars, the ethical questions center on their welfare and support. As there are thousands, then tens of thousands, new questions emerge. What is the relationship between the Mars settlements and Earth? Should they remain politically subordinate to Earth governments? Should they develop their own independent political structures? How should resources be distributed between Earth and Mars? There is a historical precedent for this question. When European colonies in North America became large and prosperous enough to sustain themselves, they gradually moved toward independence. The American colonies developed their own local governments, their own economic systems, their own cultural identity distinct from England. Eventually, they sought independence from British rule. Something similar might happen with Mars. As the settlements grow, as they become self-sufficient, as a native Martian population develops with its own identity and interests, the settlements might begin to see themselves as distinct from Earth. They might develop political aspirations toward autonomy and eventual independence. From Earth's perspective, this might be viewed as a loss, the separation of a part of human civilization. From Mars' perspective, it might be viewed as a natural maturation, the emergence of a new independent civilization. The ethical challenge would be in negotiating this transition in a way that is mutually beneficial and respectful. Earth and Mars have different interests and needs, but they also have deep connection. The Martians are descendants of Earth, share Earth's biological heritage, draw on Earth's vast accumulated knowledge and culture. The ethical question becomes, how do we develop relationships between Earth-based and Mars-based human communities that respect the legitimate interests and autonomy of both, that maintain cultural and scientific connection, that avoid domination by either side? This is not an unprecedented question. We face similar questions on Earth, regarding relationships between different nations and different ethnic and cultural groups. We have not solved these problems. We continue to struggle with questions of justice, equity, power, and autonomy, but we have developed some frameworks and processes for negotiating them. These frameworks might prove useful in negotiating relationships between Earth and space settlements. Imagine now, if we can, the perspective of a person who has lived for years on Mars, who has become at home in that strange landscape, yet who has never fully lost the connection to Earth. They wake in their Martian habitat to the sound of life support systems, the gentle hum of ventilation, the occasional click of equipment cycling. They open their eyes to an artificial light that simulates the dimmer light of Mars by late afternoon. They rise and move through corridors and chambers that are familiar now, that feel like home, yet are entirely artificial, entirely constructed by human hands in defiance of the harsh environment outside. They step outside, a process that requires donning a suit, checking systems, passing through airlocks. They emerge onto the Martian surface. The ground beneath their feet is rust-colored dust and stone. The sky above is butterscotch, pale and strange. The horizon curves slightly differently than Earth's horizon, a consequence of Mars' smaller size. They have stood on this surface hundreds of times. They know the particular features of this landscape, the rocks with specific shapes, the patterns of dust, the way the light falls at different times of day. They have become intimate with this alien world in a way that is no longer mediated by instruments or vehicles. This has become their landscape, their place. Yet when they look up at the night sky, they can sometimes see it, a blue-white star among the other stars. That is Earth. That is home, in the sense that they were born there, that their ancestors lived there for millions of years, that human civilization remained centered there. Somewhere on that distant star circle is the place where they were born, the people they loved, the landscape they grew up in. It is impossibly distant. It is unreachable. It has become mythical, a place they remember, a place they knew, but a place that is no longer home. They have made peace with this. Or perhaps peace is too strong a word. They have accepted it. They have incorporated it into their sense of self. They are no longer Earth human or Mars human. They are something new, something that belongs to both worlds, yet is fully at home in neither. Yet in another sense, they have come home. They have found their place. The work they do has meaning. The community they are part of is genuinely theirs. The future they are building matters. They are not exiled. They are not lost. They are colonists, pioneers, founders of a new world. They are, in the deepest sense, home. There is something eternal and mythic about the image of the space colonist, the person who leaves Earth and does not return. It echoes the great myths and stories of human departure and transformation. It echoes the story of Odysseus leaving Ithaca, the wanderings, the question of whether he will ever return home. It echoes the story of migration and settlement that has defined human history. It echoes the spiritual traditions that speak of leaving the world of illusion for some greater realm. It echoes the hero's journey, the departure from the known world into the unknown, the transformation that takes place in the strange lands, the difficulty of return. But unlike the mythic hero, the Mars colonist does not return. There is no final homecoming, no moment of recognition, no return to the place of origin. There is instead a permanent transformation, a permanent departure, a permanent remaking of self and home. This is melancholy in some ways, the loss of the possibility of return, the finality of the choice. But it is also liberating. It means that the Mars colonist does not live in a condition of perpetual longing for return, of viewing their current life as temporary and provisional. They must commit fully to their new home, must accept its reality, must find meaning and satisfaction within it. In this, they are ahead of the rest of us. Most people, most of the time, live in a state of partial commitment. We are always partly elsewhere, imagining different circumstances, different places, different lives. We are always aware of alternative possibilities, roads not taken. We maintain a kind of psychological mobility. The Mars colonist, by accepting the permanent nature of their exile, achieves something like psychological peace. They are forced to fully commit to where they are, to making that place home, to finding completeness in their current circumstances. This is the gift and the cost of permanent exile. It is loss, but it is also clarity. It is deprivation, but it is also focus. It is separation, but it is also belonging. In the end, the question, why will anyone who goes to Mars never come back, can be answered in multiple ways. There is the scientific answer, the physics of interplanetary travel, the fuel requirements, the energy expenditure necessary to escape Mars' gravity and return to Earth, makes return impractical and economically unreasonable. There is the biological answer. The adaptation of the human body to Martian gravity makes return to Earth's stronger gravity difficult and potentially damaging, and the longer one stays on Mars, the more difficult return becomes. There is the psychological answer. After years on Mars, the settlements become genuinely home, attachment to Mars grows, and the desire to return diminishes, while the sense of connection to Earth, though it may remain, becomes increasingly distant and attenuated. There is the civilizational answer. Humanity is expanding beyond Earth, establishing new centers of civilization on other worlds, and this expansion requires the commitment of people willing to settle permanently, not merely to visit and return. But perhaps there is also a deeper, more philosophical answer. Perhaps the reason that no one who goes to Mars will return is because Mars settlement represents a fundamental choice about human nature and human meaning. It represents the choice to commit fully, to sacrifice personal mobility and choice in service to something larger, to build community and meaning through investment in a place and in people rather than through the accumulation of experiences and options. We live in an age of mobility. We expect to be able to travel freely, to change our circumstances, to move between places and people. The possibility of return, of being able to reverse our decisions, of maintaining options and possibilities, this is central to modern consciousness. Mars settlement, by being one way and final, represents a return to something older, something more traditional, something perhaps more human than the constant mobility we have come to expect. It represents the choice to plant roots, to stay, to make a commitment that cannot be reversed. In this sense, the Mars colonists are not victims of circumstance. They are not exiled against their will. They are choosers of their own exile, acceptors of permanent separation from Earth, dedicated to the project of building a new home, a new community, a new center of human civilization. This requires courage. It requires faith. It requires a kind of nobility that has become rare in contemporary culture. But it is not unprecedented in human history. It echoes the choices made by countless pioneers, settlers, explorers, and people of faith throughout human history, people who chose to leave the known world and commit themselves to building something new in unknown lands. And yet, for all we have imagined here, the future remains open. The first humans have not yet stepped on Mars. The first permanent settlements have not yet been established. The first generation born on Mars has not yet grown up. The culture of Mars, the meaning of Mars, the role of Mars in human future, all of this remains ahead of us, unwritten. Different futures are possible. Humans might go to Mars and establish settlements, as we have imagined. Or humans might focus on other destinations, the Moon, asteroids, other moons of the solar system. Or human civilization might turn inward, focusing on solving problems on Earth rather than expanding beyond. Or something entirely unexpected might happen, a new technology that changes the equation, a new priority that redirects resources, a new vision of what human future should be. We cannot know which of these futures will come to pass. But we can know that the choice is ours. We can know that the visions we create, the dreams we hold, the commitments we make, shape the futures that come to pass. The Mars colonists, if and when they depart Earth for the one-way journey to Mars, will be making a choice about what kind of civilization we are, what kind of species we are, what kind of futures we believe are possible and worth pursuing. They will be saying, through their choice, we are a species willing to venture beyond our native world, willing to accept permanent exile from our world of origin, willing to commit our lives to building something new in a place that has never known human presence. This is an assertion about human nature. It is a declaration that we are not bound to Earth, that we are capable of transcending our origins, that we are capable of choosing meaning over mere safety, commitment over mere preservation. It is also, in the end, an act of hope. Hope that human civilization is worth extending across the solar system. Hope that the future on Mars will be better than the sacrifice required to build it. Hope that the commitment the colonists are making will contribute something valuable to human history and human meaning. These colonists will never see Earth again. They will never walk in a forest, or swim in an ocean, or feel rain on their faces. They will never visit the places they loved or be in the presence of the people they cherished. They will spend their lives in artificial environments, in constrained circumstances, doing difficult work. But they will also be pioneers. They will be founders. They will be the beginning of something new. They will be home, in their way, on an alien world, having made a home from stone and dust and human determination. And perhaps, in the end, that is enough. Perhaps that is more than enough. Perhaps that is the full measure of what it means to be human, to be capable of leaving home in service to something larger than ourselves, to be capable of choosing new homes, to be capable of extending our civilization across worlds, to be capable of sacrificing present comfort for futures that we will not see but that we believe are worth building. The spacecraft descended through the thin Martian atmosphere, slowing from orbital velocity, homing in on the landing site that had been selected months ago. In the cabin, the first humans to arrive at this settlement were strapped into their seats, watching the screens that showed the rust-colored landscape rising up to meet them. No one spoke. The moment was too large for casual conversation. This was not merely a journey to a new place. This was a departure. This was the moment where lives would diverge from all previous possibility, where a choice made years ago, studied and accepted and prepared for, would become irreversible reality. The spacecraft touched down. Dust rose in billows around them, and slowly settled. For a few moments, there was silence. Then, gradually, the soft sounds of systems powering down, of air cycling, of the basic infrastructure of the habitat awakening around them. The first person moved toward the airlock. They were followed by others. They opened the hatch and descended the ramp, their boots. Never mind the suit, never mind the helmet, imagine just the boots, touched the surface of another world. They stood for a moment, looking out at the landscape. The sun was low on the horizon, sinking toward dusk. The sky was butterscotch, fading to pink and blue at the horizon. In the distance, the rim of a crater caught the last light. The landscape was utterly alien, utterly barren, utterly beautiful. And in that moment, standing in that strange landscape, with Earth hanging somewhere up there in the darkening sky, impossibly distant, unreachable, becoming something more like memory than home, they understood with perfect clarity. They would spend the rest of their lives here. They would never return. They would die on this world. This rust-colored landscape would be their home. There was no regret in this understanding. There was sadness, perhaps, but sadness mixed with something else. Purpose, meaning, the clarity that comes from knowing exactly what one has chosen and committing fully to it. They had come here to stay. They had come here to build. They had come here to plant roots in a world that had never known human presence. Above them, the stars began to appear. In the distance, something like thunder echoed across the plain, a dust devil, perhaps, or just the wind across the empty Martian landscape. The light continued to fade. The dusk deepened toward night. And in that night, on that alien world, with Earth a distant memory and the future opening up in front of them, the first permanent human settlement on Mars began. This is the truth we have been circling, that to go to Mars is to understand, in the deepest sense, what it means to truly stay somewhere. Not to visit, not to explore and return. Not to maintain the possibility of return, but to commit absolutely, finally, to a place and to the project of building something there. It is to understand, perhaps more clearly than those of us who remain on Earth ever can, what home truly means. Home is not a location. It is a commitment. It is the decision to invest your life in a place and people, knowing that this decision is permanent, that the future you build will be built in this place, that when you die, you will become part of this landscape. The Mars colonists, by accepting the permanence of their departure from Earth, will have learned something that might be valuable for all of us. What it means to belong completely to a place, to have nowhere else to go, to have no option but to make home in the place where you find yourself. Perhaps in the end, that is the greatest gift that Mars settlement could give to human consciousness, not technological advancement, not access to resources, not even the expansion of human civilization across the solar system, but the recovery of understanding what it means to truly go home, to truly belong, to truly commit yourself to a place and a community and a future. The Mars colonists will go to Mars knowing they cannot return. They will spend their lives in alien landscape. They will face hardship and isolation and the loss of everything they have known. But in doing so, they will be participating in one of the most profound and ancient aspects of human nature, the willingness to leave home, to venture into unknown territory, to commit ourselves to building something new in a place that has never known human presence. This is what we are. This is what humans do. We leave. We explore. We settle. We build. We commit ourselves to places and futures that we may not live to see completed. And in doing so, we honor both the worlds that we leave and the worlds that we come to inhabit. The Mars colonists will never return to Earth, but they will come home, in the deepest sense, to Mars. And in doing so, they will teach us all what it means to truly go home.